Hi friends and my dear students. In Physics second volume, 12th standard, Atom Models 8.3, Atomic and Nuclear Physics. Many scientists are discussing about the atom model to explain the structure of the atom. Before that, we must clear about what is an atom. Atom is nothing but a tiny particle. A tiny particle. Suppose if you are consider any object like this, any object or every object, to continued subdivision ultimately yields to an atom. If you are divided again and again, at last the size may be reduced. At last it becomes indivisible particle. Normally, that is called an atom. This is called an atom. There is a fundamental explanation of an atom. Even though it is very tiny, it is not the entity of the particle. This is not the fundamental particle of atom. What is the fundamental particle of an atom? Then we have to consider about the structure. That's why many scientists are concentrated to explain the structure of the atom. The first scientist who came and gave valuable experiment of explanation of the structure of the atom, Thomson who gave this valuable suggestion regarding an atom. Atom is nothing but a spherical sphere, and the whole positive charge are evenly distributed throughout the sphere, not only any particular point, but the whole positive charge are evenly distributed. What is meant by evenly distributed? If you are bifurcated this sphere into half, then it is in two parts. Then half the positive charge of this, half of the portion, both are equal. Such a manner, when you are bifurcated into four, then four are equal in positive charges. That's the even distribution. That is the even distribution of these positive charges. These are all positive charges. Suppose, whereas the electron are embedded inside the nucleus, like this as shown in the figure. These are all called electron. It is nothing but just like a watermelon. It is like a watermelon fruits, like that. The reddish part is called positive charge. Reddish part is called positive charges, whereas the electron are at the center, or not only in center, embedded anywhere else inside the spherical. This atom model cannot be explained and cannot be accepted only because as per the nuclear or electrostatic configuration, according to this model, all charges are assumed to be at rest. But from classical electromagnetics, no stable equilibrium points exist in electrostatic configuration. That's a very important thing. If suppose which are in the stable manner, it cannot be explained the stability of an atom. That's the first point why we are neglecting this atom model. Why we are neglecting this atom model? The stability of an atom model cannot be explained. Or simply you can understand one positive charge and negative charge are accumulated at the same point. Both are destroyed to each other. Then there is no electron, there is no positive charge inside the nucleus. Then it is destroyed to each other. That's why the stability cannot be explained by the Thomson atom model. The second thing, when we took a spectroscopy photo, we get a line spectra, but Thomson cannot explain the reason why we got line spectra. This cannot be explained by means of Thomson, so this atom model was not accepted. This was not accepted. Even though the atom are visualized as a homogeneous sphere which contains a uniform distribution of the positive charges throughout the sphere, the electrons were embedded inside the nucleus. It was wrong, because as per the electrostatic theory, the old physics scientists explained that the stability cannot be explained, so that the atom model was neglected. Now, there is one 3-mark question here. Explain Thomson atom model. You have to write only in 3 sentences. Atom is considered to be a sphere and hold positive charge are evenly distributed throughout the sphere. The electrons are embedded in the inside the nucleus. That's the explanation of the Thomson atom model. Then you will get 3 marks. The another 3-mark question: why the Thomson atom model was neglected? Because as per the electrostatic theory, the static electron or positive charges which cannot explain the stability of an atom. The second thing, Thomson unable to explain the reason why we are getting line spectra. These 2 things cannot be explained by the Thomson atom model. That's all. This is the second 3-mark question. Okay. Now we have to shift over to some other scientist atom model. By Thomson atom model, then assistant of Thomson, who gave his valuable theory of Rutherford. Again, one by one scientists, another scientist, Geiger, Marsden, then Niels Bohr, they all gave their own theory according to the structure of the atom. Before going to see the Rutherford atom model, we have to consider alpha scattering experiment. Alpha scattering experiment. What is in the alpha scattering? Alpha scattering is nothing but that you consider a lead box which are not, it is considered to be non-conducting it is non-conducting of radiation. That's why it is not allowed radiation through this wall, such that it may act as a shield. That's why we have to consider a lead box as shown in the figure, and we have to consider a radioactive substances of polonium or radium or thorium, anything else. Polonium you have to consider here. Then there is a fully tightly closed, only here there may be a hole, so that this radiation may take over path or passage through this hole itself. It may hit the lead plate up and down. For this, why we are using this lead plate? Suppose if the electron are scattered like this, then it may converted to a ray, converted to a pencil-like beam of ray. That's why we are again considering lead plate to channelize this scattered electron into a pencil-like beam or a ray. This is called incident ray. Now we have to fix in presence of in front of this cathode, radiation ray. The radiation is nothing but alpha particle. Alpha particle means positive. When you think about radiation, there may be three kinds of radiation. One is alpha, it is nothing but 2He4, helium, or purely positive, The second one is called beta, that is called negative. Third one is gamma, this is called radiation, that is energy. There is no charge. That's why here in this case we are considering only alpha particle of positive charges which are traveled through the cold file. This is called cold file we are having here. What happened here? Whenever this alpha particle hit the surface of the cold file, what happened? Then it may be scattered in all direction up to 0 degree to 180 degree. Now we have to fix a screen made up of zinc sulfide coating. Zinc sulfide coating are capable to move from 0 degree to the 180 degree. This is a setup arrangement attached with the microscope. What is the use of microscope? Whenever the alpha particle hitting the surface of the zinc sulfide, that point are illuminated, that point are glow, or a spark may able to utilize, spark may be happened. That's why through the microscope we are able to visualize the spark or illumination or the glorious spot. That's why both are attached together and move from 0 to 180 degree, so that we can calculate. This is called the smallest angle from the starting point. Then again you can change the theta likewise, or you can increase the scattered ray angle, so that you have to make a tabulation, and we can get a result through this experiment. And because of this experimental, he at last came a conclusion. That's the thing very important that we are going to explain now. This is alpha scattering experiment. This alpha scattering experiment is a very important concept to explain all the positive charges of the atom are accumulated in the smallest area. All the positive charges of an atom which is accumulated or concentrated in a smallest area, that is called nucleus, whereas remaining portion all are empty. These are all empty. There is a vacuum. Here only positive charges, because here proton as well as neutron, neutral particle. This is positively charged particle. That's why nucleus of an atom is totally considered to be a positive. Whereas if you are thinking about an electron, the electron are in the orbital or in the shell orbital, then which is not in the static, then it revolving this nucleus continuously, revolving the nucleus continuously in the orbital itself. That's the thing that he concluded. How can he concluded regarding this is positive and electron to be here? That's the thing that we are going to explain now. Now, let you imagine alpha ray of various angle like this, like this. Suppose if you are applying, these are all alpha particle, these are all alpha particle. When alpha particle towards the nucleus at the center, it may repel in the same direction. It may repel in the same direction. Whereas if you consider a ray just away from this, just away from this nucleus, or straight away moved, straight away here or straight away moved. There is no deviation in the path. But whereas very closer to the nucleus may be repelled more than nearly about more than 180 or 360 degree. In case if you are very closer, then the reflection may happen more than 90 degree. If it is kept away from the ray, it will be slightly reflected. From this, there may be a reason why this ray, positive rays, these are all positive rays. The positive rays which will be reflected when closer to this nucleus, if travel just away from this nucleus, which are not affected, that's why he concluded that there may be a accumulation of all positive charges in the smallest area called 10 power minus 14 meter. The radius of a nucleus are assumed 10 power minus 14 to 10 power minus 15 meter as per Rutherford. Atom model. Again, so now, what is the definition of the Rutherford atom models? 3-mark question. If suppose they ask any question, define Rutherford atom models. Atom model is nothing but a spherical sphere. Whole positive charge are accumulated in the smallest area, and it may called as a nucleus. The electron are in the orbital are continuously travel in the orbital itself. That's the thing that you have to write. That's a 3-mark question. Then, why it was neglected? First 3-mark, second 3-mark, why atom model was not accepted? Why Rutherford atom model was not accepted? The first reason is a major reason. If any electron which are this is considered to be a nucleus or electron to be in the orbital. If any electron are continuously revolving, then when you consider this is called a straight line in the Earth surface. When you roll over any ball, then the ball become at rest at any time. Rest because it continuously losses of its energy, so that at last it came to an rest. In such a manner, if you think about the electron movements, it are continuously revolving, so that the path of the electron not a spherical but a spiral. That means the radius of the electron, which are continuously reduced, at last it collision to the nucleus. This is negatively charged and this one is positively charged, both are combined to each other, then again, as per the electrostatics, then there is no stability. There is no stability of an atom. Both are destroyed to each other. That's why the atom cannot be explained the stability of atom. That's why Rutherford atom model was not accepted. First point. Are you clear? Okay. The point, second point, if you allow to take a photograph, there may be a line spectra. There may be a line spectra for an atom. Here the electron are continuously emitting the radiation. That's why he got only a continuous spectra instead of line spectra. He got only continuous spectra instead of line spectra because it is the electrons are radiated their energy in continuous manner, so that as per Rutherford atom model, we are getting only continuous spectra instead of line spectra. That's why this atom model was not accepted. That's a very important concept to understand the Rutherford atom models. Again, we have to explain this, the very important 2-3 marks. One is called the minimum distance or the distance of closest approach. What is the closest approach? When the alpha particle move just sideline to the nucleus, then it may reflected before the center of the atom to the particular distance. This distance is called R0. That value is called distance of closest approach. Before entering the orbital or nearby the electron, it may be repelled. That the distance is called closest approach. Here, the minimum distance between the center of the nucleus as well as the alpha particle just before it gets reflected back through 180 degree is defined as distance of closest approach or not. This is a valuable 3-mark question. Another thing, if you convert this alpha particle energy completely to the nucleus, then of m v naught square, that is equal, as per the Coulomb's inverse square law of electricity, we already studied in the first one, 4 pi epsilon naught into 2e into ZE. That's a very important concept. By distance, the radius is called R square. Here, if you consider to be R0, then R0 square, or 1 by 4 pi epsilon naught 2z e square by R0 square. This is the most valuable equation for explaining this concept. Now we want to find out the value of R0 square, R0, near R0 itself. Therefore, if you are bringing to the R0 to the upper, then what happened here? 1 by 4 pi epsilon naught 2z e square divided by m v naught square 1 by 2 m v naught square. This is nothing but the kinetic energy Instead of that, you have to put the value of k. This equation is not utilized for any other purposes, only to identify the radius of this nucleus. That's alone. Remaining, you are not utilized this formula. You have to know and study about the concept. This equation, with the help of this equation, we conclude that Rutherford conclude that the radius of a nucleus, it may be equal to 10 power minus 14 or 10 power minus 15 meter. This is the most valuable concept to understand. Then impact parameter. At last 3 mark question. What is meant by impact parameter? Impact parameter is nothing when sorry, you have to consider alpha particle like this. This is travel in straight line manner, or it may be deviated like here itself. Then if you extended the path in the straight line path as shown in the figure, you have to consider the nucleus here. This is called nucleus. Then the directed distance, this is called p. This is called impact parameter. That means if you are extending the alpha particle ray in the straight line path, the perpendicular distance between the extension and the center of the nucleus is called impact parameter. When you increase the impact parameter, when you reduce the impact parameter, the deflected or scattered value become high. When B is less, theta is high. When B is high, theta is less. That is a very important conclusion from this impact parameter. This is another 5-mark question, or 3-mark question. There are 1 5-mark question, Rutherford experiment, remaining all 2-mark question and 3-mark question and 1-mark question. This is the most valuable things that we have to understand clearly. Now, before that, Rutherford concluded that 4 important points. The one is, most of the particles are traveling in straight-line manner, and very nearer to the particle, those are just deviated, or 1 by 1000 particles are deflected in more than 90 degree, or very lesser particle are returned back more than 180 degree. This is the 4 point that he concluded from this experimental of alpha scattering experiment. This is the basic concept that you understand this atomic structure. Next we are going to see Niels Bohr atom model, and very fine and important question also. Today, next class we have to see. Thank you, my dear students. Thank you very much.